Okay. Let's say I have a situation where I have a block sliding down an incline. Well, this free body diagram isn't as easy as the one with a force being pulled at an angle. Okay, so there's a few different things about this free body diagram that we need to keep in mind when we're going to go through. The first one is that notice that my x-axis is tipped. And the reason for that is because my x-axis then is parallel to my surface. And my surface is this incline. So my x-axis is tipped like that. So I'm just going to kind of tilt, right? So it looks like it's up and down because it doesn't particularly matter with how we're doing it. It just changes how we're going to analyze this situation. Now, when I'm looking at this, there's a few things I need to keep in mind when going through this. The first being this. My gravitation force is always straight down. So if I have a force at an angle, like this one is, I'm on an incline like this is 90 degrees. Which means that if I had this triangle, then this angle of the triangle is 90 minus theta. Which means that this little angle in here has to be theta. Well, that actually makes our life a whole lot easier knowing that that angle is theta. Because then when we get, if I just kind of pull this vector out here and I put it over here, and I say, oh, well, there's a vector, and oh, there's a vector. Well, this is actually the gravitational force down the incline, or the mgx vector. And this is actually the gravitational force into the incline, or the mgy vector. And what I just showed you was that this angle is the same as the angle of the incline. And that's important because that helps us break apart this gravitational force vector, which is at an angle not along our x or y axis, into its components. So I'm going to bring this mgx component down here because it's just moving the vector to a different position. And I can see that this shows how my gravitational force breaks up on an incline. And this will always be true, that the angle of my incline will always be this angle between my gravitational force and my y-axis. So with that being the case then, my mgx vector becomes m times g, or my weight, right, times the sine of my angle, which is a little different than what we saw with forces at an angle, which is why it's important to pay attention to how that angle is derived and what that triangle looks like. Whereas my weight vector in the y direction, that's into the incline, is mg, or the weight, times the cosine of my angle. Okay? That's really important to keep in mind because that is something that does get mixed up frequently. The acceleration of the block is down the incline and parallel to the surface. There is no acceleration perpendicular to the surface since the block remains in contact with the incline for the entire slide down the incline. Okay, so that's just the first part of it, but let's actually draw our whole free body diagram here. So I'm going to go and I'm going to say, just like it did, here's my x, here's my y, and I'm going to finish off my free body diagram because the only thing I really have right now is mg. Now in this case, I know that there's going to be some normal force holding the block up. And for the sake of making it a situation where it's a little bit easier to analyze further, let's say there's a frictional force which is opposing the motion of the object. So there's some frictional force up the incline. And what's pulling the block down the incline is the mgx portion of my force, this gravitational portion which is in the x direction. So that might be what my free body diagram were to look like if I had friction. Now, if this were some sort of a frictionless scenario, then this vector would not exist. I would not have any friction. Okay, so if I'm trying to find my acceleration in my x direction, then I need my net force in the x direction. Well, here's my x direction. I'll say down my incline is my positive direction. I'll say up my incline is my negative direction because that's the opposite direction of the motion. So then down my incline, I have this mg sine theta. And up my incline, I have this frictional force. And that's all I have in my x direction. So then there would be my x direction Newton's second law equation to go along with my free body diagram. In my y direction, I need the sum of my forces in y direction divided by my mass. Notice this is my y direction. I have a normal force, which is up out of the incline, so I'm going to say my normal force minus, now my into the incline force is my mgy, so mg cosine theta, and that's it, divided by my mass. Now it says here that there is no acceleration perpendicular to the surface since the block remains in contact with the incline during the entire slide. So AY equals 0. There's no perpendicular to the incline acceleration, which means my net force in the y direction equals 0. Okay. Solve for the normal force. So again, solving for the normal force is one of those common problems that we need to keep in mind as we're going through looking at an inclined plane problem. Well, this is my equation with my normal force, so again, I'll rewrite it down here. AY is Fn minus mg cosine theta divided by my mass. I said before that, my acceleration in the y direction is 0, so I'll make that 0, and I'll multiply the mass to both sides, and I get Fn minus mg cosine theta. Well, we know that anything times 0 is 0, so we don't need to worry about that. So we get 0 equals Fn minus mg cosine theta. I move the mg cosine theta to the other side, and I can see that my normal force in this case is going to be equivalent to the gravitational force into the incline. Okay, quick review of what we saw. If I have an object sliding down an incline, then the angle of the incline is always going to be equivalent to the angle between my gravitational force, which is always downward, and my y-axis. And because of that, I get this breaking apart of my weight force, or my gravitational force, that looks like this, where down the incline, or parallel to the incline, is mg sine theta, and into the incline, or perpendicular to the incline, is mg cosine theta. And then, just like before, I'm going to write my Newton's second law equation to go along with each, based on my whole free body diagram, not just my weight force, and go from there. And in this case, I asked you to solve for the normal force, so then we go through, we do some algebra, and we solve for the normal force.